Good morning. This is elementary algebra. I am your instructor, Amy Fuchsteiner, and we are working on our last section from chapter 3 today. We're going to look at the point-slope form of an equation, slightly different than the slope-intercept form. We're going to use the point-slope form, excuse me, to write the equation of a line. Let's see if I have anything. Perfect. We're going to use the point-slope form to write the equation of a line when we have 2 points. We're going to talk about or look at what happens when your line is horizontal and vertical. And again, we're going to use the point-slope form to model some data and write the equations of that data. We got to start with the basics. What is point-slope form? The point-slope form of a line looks like y minus y1 is equal to m times x minus x1. Where m is the slope and x1, y1 is a given point. So to begin with, to start this off, we are going to give you a point and a slope. And we're going to use those two pieces of information to write the equation of the line. Why do we want you to be able to write the equation? Well, we want you to have skill with equations of lines moving forward and moving backwards. Basically, we want you to not only be able to graph a line and get information from that graph, such as points and slopes, but we also want you, when given a graph, when given points and slopes, to work that magic backwards and give us the equation of the line. And so that's what this topic is today. We are giving you information and asking you to work it backwards into the equation of a line, right? Some examples I'm going to go through to start. We're going to get the slope and a point, and we're going to write the equation of the line for the very first problem in slope-intercept form. So using the point-slope form, that is the y minus y1 equals m times x minus x1. We know from the problem that m is equal to 4, and our x1, y1 is coming from the point 2, 7. Okay, we have a slope of 4 that passes through the point 2, 7. So the slope of 4 gives us our m of 4, and we're passing through the point 2, 7, so that's going to be our x1 and our y1. Now, it's just a matter of plugging our values into the point-slope form and then simplifying. When we first plug them in, we will have y minus y1. Remember, our point is 2, 7. So this is our x1 and this is our y1. This y, see how that y doesn't have a subscript? That y without the subscript is the one that's staying in our problem. So this will be y minus 7 is equal to our m value, which is 4. X does not have a subscript on it. That's the one that stays in our problem, minus our x1 of 2. This is point-slope form. If I want to put it into slope-intercept form, that's y equals mx plus b. So I've got a little bit of work to do here. Y minus 7 will stay the same. I'm going to distribute that 4 for x minus 8. Now, the y is not isolated to get it into slope-intercept form. So I'm going to add 7 to both sides. What in the yellow? add 7, add 7. And we have y is equal to 4x minus 1. This is now the equation of the line in slope-intercept form. My slope is still 4. And if I put if I put x in, I have 4 times 2, which is 8, minus 1 does give me a y value of 7. So my slope is 4, and the point checks in the equation. Whew. For a minute there, I didn't think the point checked. That was going to be rough. Okay. Part 2 says to write in standard form the equation for a line with a slope equal to a negative 1/2 that passes through the point negative 4, 3. Remember, this would be our x1 and our y1. So using the point slope form, I have y minus y1 equals m x minus x1. I know from the problem that my m is equal to a negative 1/2. I know that the x1 would be a negative 4, that the y1 would be a 3, and that they want the final equation in standard form. That's ax plus by is equal to c. Okay, so I've got to get in a slightly different form. We haven't done a lot of this until we got to today. So, all right, substitutions. The y without a subscript stays the same. So this will be y minus 3 is equal to a negative 1/2 x minus a minus 4. Be careful there. Minus a minus 4. That's a plus 4. Okay. Now, I want this in standard form. Notice there are no fractions here, that my a should be positive. So I'm going to show you a slight trick. It's not really a trick. It's not really. I'm just going to multiply both sides of this equation by 2. Kind of like we did when we were doing the LCD stuff. That's going to give me 2y minus 3 is equal to 2y, or 2 times a negative 1/2 is going to be a negative 1, x minus 4, x plus 4, sorry. Do you remember we talked earlier when we were solving equations? This multiplication can only go to the outside. What's inside these parentheses are protected. It's like you've got a blanket thrown over the top of that x plus 4, and you're not going to go inside of it. Okay? So, can simplify this a little bit now. So 2y, that should be a 6. Good catch, Amy. 2 times y is 2y, 2 times the 3 is minus 6. So it's going to be 2y minus 6 is equal to a negative x minus 4. I need to put this into standard form, so I want my x's and y's on the same side. That means I need to do something I don't normally do here, and I'm going to add x to both sides. It's going to give me an x plus 2y minus 6 is equal to a negative 4. And then I'm going to I'm going to add 6 to both sides. I'm thinking ahead. My apologies. I'm going to add 6 to both sides, giving me x plus 2y is equal to 2. Okay. The slope in this format would be the opposite of b over, or the opposite of a over b. So my m would be a negative 1/2. And if I put negative 4 in and a 3, so negative 4 plus 6 is indeed 2, it would check with the point. Right? Want to try those again? Let's try those again. Okay. Right? Using point slope form. write the equation of a line with a slope of 3/4 through the point -5, -2 in slope-intercept form. Okay, so we've got a y minus y1 because we're using point slope form. Is equal to mx minus x1. I know that my m is 3/4. I know my x1 is a -5. I know my y1 is a -2. And I know I need slope-intercept form. I need it y equals mx plus b. There's a lot here, but it helps to write it out so you know what you need. All right, substitute. The y without the subscript stays the same. Y is y minus y1 is a -2. So y minus a -2 is equal to 3/4 x minus a -5. Now, if you can do that in one step, that's fine. Minus a -2 would be y plus 2 is equal to 3/4 x plus 5. All right. I need this in slope-intercept form. So I need to isolate my y. This would be y plus 2 is equal to a 3/4 x plus. How do I do 3/4 times 5? This is why we had you practice fractions. I don't want you to write this as a mixed number. I don't want you to write this as a decimal. 3/4 times 5 is the same as 3/4 times 5/1. 3 times 5 is 15, and then it stays over the 4. So 15/4. Now I need to subtract 2 from both sides. When you're subtracting 2, which is not a fraction, from 15/4, which is a fraction, you need to change this to a common denominator of 4. How many fourths do you need to make a 2? -2 is the same as a -8/4. This would be y is equal to 3/4 x plus 15/4 minus 8/4 is 7/4. All right, I should have a slope of 3/4. I do. If I put in an x as a -5, that would be a -15/4, right? If I put in a -5 there, if I add 7 to a -15, I get a -8/4, which is a -2. They all work. So this is the correct answer. I would add, you can use a calculator for this. Just watch your formats. All right, write in standard form the equation for a line with m is equal to -1 that passes through the point to -1. Okay, I like that the numbers are better. I like that the numbers are better. Point slope form is y minus y1 is equal to mx minus x1. We know from the problem that our m is a -1. Our x value from the point is 2. Our y value, or y sub 1 from the point, is -1. And I want it in standard form, which is ax plus by is equal to c. Substituting in what I can. The y without the subscript stays the same. So this would be y minus a -1 is equal to a -1 times x plus minus 2. Minus a -1 is y plus 1, -1, x minus 2. Simplifying, I have y plus 1 is a -x plus 2. Negative, positive. Now, I need to get this into ax plus by equals c form. No fractions. No fractions. Now I need to make sure I get x and y on the same side, and I want to show x first. So I'm going to add x to both sides. This gives me x plus y plus 1 is equal to 2. Then I'm going to move that 1 Oops, sorry. Off script. Then I'm going to move that 1 by subtracting it from both sides. So x plus y is equal to 1. Okay, let's check it. If I put in a positive 2 and I subtract 1, do I get a 1? I do. The slope should be the opposite of a over b, or a negative 1 over 1. Yeah, okay. There we go. All right. I have written the equation of the line using point-slope form. If I know the slope and a point, now we're going to kick it up a notch because that's what we do here. And we're not going to give you the slope. Instead, we're going to give you 2 points. But the beauty about this is that 2 points will determine a slope. So, if you know 5 and negative 2 and 7 and negative 1, you can find the slope yourself. The slope would be negative 1 minus a minus 2 over 7 minus 5. So now that's going to be a 1 over 2, or 1/2. And that's a fine thing. I know that my slope is 1/2. Oops. Why did I put an extra m? I don't know. Pretend it's cursive. Maybe it's cursive. All right, so my m is equal to 1/2. Now, in order to use point-slope form, y minus y1 equals m times x minus x1. I've now got my m of 1/2. I now need an x1 and a y1. And here's the thing. It does not matter which point you use. I can use the 5, negative 2 or the 7, negative 1. Doesn't matter. Doesn't matter one bit. Now, there are some efficiency points here. There are some sort of planning aheads. One of the things I do is I look for a point with 0 in it. Because if the point has 0 in it, that will make my calculations easier. There's no zeros here. The second thing I do is look for positive numbers. Because as I've stated, I tend to be bad at negatives. Both of them have a negative, so we're still at a toss-up. The third thing I want to do is, since m and x get multiplied, I have a slope with a denominator of 2. So if at all possible, I want to choose an x value that 2 goes into. My x value choices are 5 and 7. 2 doesn't go evenly into either of those. So in this particular case, I am all out of luck. It will not matter. No point is going to be more efficient than the other. So I'm just going to choose like an x1, y1, and I can let it be either point. I'm just going to say 5, negative 2. Okay? Doesn't matter in this case at all. All right. So now let's make the substitutions. Remember, the y without a subscript stays the same. Minus your y1, so minus a minus 2 would give me a plus 2, is equal to 1/2, that's my m, and then it will be x minus the x1, which is a 5. Okay, I need it in slope-intercept form. Slope-intercept form is y equal mx plus b. So I can now simplify this and isolate it for y. So it's going to be y plus 2 is equal to a 1/2 x minus, think of this as 5 over 1. So 1/2 times 5 over 1 is going to be a 5 over 2. Now to isolate the y, I need to subtract 2 from both sides. 2 as a fraction. I don't know why it does this, but hey, we'll get it. Okay. 2 as a fraction would be a 4 over 2 negative. So now I've got y is equal to a 1/2 x minus 5 over 2 minus 4 over 2. That's going to be a minus 9 over 2. And there we go. There's my equation. It's actually pretty straightforward. If you don't have a slope, find a slope. Use the 2 points you're given to find the slope. So for number 2, we've got the same type of problem. Write the equation that passes through the points in slope-intercept form. So I don't have a slope. For point slope form, y minus y1 equals mx minus x1. I need to know a slope. So my slope here would be a -1 minus 0 over 2 minus 4. That's a -1 over a -2, which is again a 1/2. Apparently I liked a 1/2. Now, remember, I said for efficiency's sake, take a good look at your 2 points. It doesn't matter which one you pick. You can always pick x1, y1. That's fine. You can always pick the first point. Not a problem. But you can also analyze the 2 points to determine which one would work better. For me, I look for a point with zeros. 4 zeros winning. I look for a point with positive numbers. Still winning. I look for a point where if I have a slope, the x value of that point is a multiple of the denominator. Is 4 a multiple of 2? Indeed it is. But so is this one. But this has the 0. So I'm going to go with this one. So I'm going to use x1 is my 4 and y1 is my 0. I need it in slope-intercept form, which is y equals mx plus b. So, all right. So now I'm going to do some substitutions. So this would be y minus y1. So y minus 0. It's okay. It's okay. I don't need to simplify it right away. It's y minus 0. Put it in there to hold the place. Think about it later. M is 1/2. And then I have x minus 4. Okay. Make the substitutions first. Follow through on the thinking bit of it in just a minute here. So now I see I can simplify this. Y minus 0 is just y. And then I need to distribute that 1/2. That'll be 1/2 times x, which is 1/2 x, minus 1/2 of 4. 1/2 of 4 is 2. You can check a point. Let's check the point we didn't do. 1/2 of 2 is 1. Minus 2 is a -1. Checks. Okay. I knew I needed a slope of 1/2, and it checks in that point. So, yes, ma'am. I'd be good. It's good. Okay. What if we've got to do standard form? It's always good to practice standard form again. Same idea here. We want you to start with point slope form. Y minus y1 equals m times x minus x1. The idea being the more you say it, the more you practice it, the more you'll remember what point slope form is. Okay? We need to know a slope and a point. I have 2 points. So I'm going to use those 2 points to determine what the slope would be. That's why we did slope first. So I've got y2 minus y1, or 2 minus a minus 3, that's plus 3, over y2 minus y1, or 1 minus a minus 1. This is going to be 5 over 2, right? I've got a 5 over 2. I can choose either of the 2 points to be my x1, y1. I can just use the first one if I want. But we've also talked about efficiency, right? I can analyze the 2 points to see which one serves me better. I have a preference for positive numbers because I tend not to mess up the signs then, and zeros. I don't have any zeros, but I do have a point with 2 positive numbers in it. So right now I'm leaning towards using the point 1, 2. Right? Now, the second thing is this has a denominator of 2. Since that slope gets multiplied by the x value, I would like to pick an x value that is a multiple of 2. The problem is both of my x values are 1. So when you skip count 2s, 2, 4, 6, 8, you're not going to get a 1. So it won't matter which one. And because I prefer positives, I'm going to use my x1, y1, y1, comma, to be the 1, 2. We need this in standard form, which is ax plus by equal to C. Okay. Now I'm just going to do my substitutions. So this would be y minus 2 is equal to 5 halves times x minus 1. All right. I've got that lovely denominator. I don't want it. So I'm going to do what we did when we were solving fractions with denominators, and I'm going to multiply both sides of this equation by that 2. Now, on the left side, I can distribute it. That will be a 2y minus 4. On the right side, the 2 can get multiplied by 5 halves. That's just going to be a 5. But it cannot go inside that internal set of parentheses. That internal set of parentheses will be like a blanket covering up that x minus 1 and protecting it from any multiplication until we decide to multiply by what's directly outside of it. Right? Okay, so now that I've got 2 times 5 halves, that would be 10 over 2, which is just 5. I can go ahead and multiply or distribute that parentheses, 5x minus 5. Now, to get into the general or standard form, I want my x's and y's to be on the same side. I have a decision to make here. I can subtract 5x from both sides. And if I subtract 5x from both sides, it's going to be a negative 5x over here. I can't lead with a negative, but we can fix that later. So I'm going to subtract 5x from both sides. So I have a negative 5x plus 2y minus 4 equals a negative 5. I need to move that minus 4. I need to eliminate it. So I'm going to add 4 to both sides. That gives me a negative 5x plus 2y is equal to a negative 1. I cannot lead with a negative. So now I'm going to multiply both sides by a negative 1. That will eliminate the negative, and I have 5x minus 2y equals 1. These are clearly a little bit more intense. I don't want to say harder because it's not necessarily more difficult. There's just a lot more steps. There's more working parts, a little bit more gears. It's the same basic process. It's just that oftentimes getting to standard form, that 5x minus 2y equals 1, is a little bit more involved. So let's try that one again. Okay. Write the equation that passes through the points, negative 5, 2, and 7, negative 1. So y minus y1 equals m times x minus x1. In order to use point slope form, I need to know a point and a slope. I do not have a slope, but I do have 2 points. So with those 2 points, I can determine the slope. The slope here would be y2 minus y1 over x2 minus x1. That's a negative 3 over 12, or a negative 1/4. Right? With that slope of a negative 1/4, I can now look at what makes sense to use of the 2 points. If you don't want to think about this, you don't have to, but a little bit of forethought can help. I prefer positive numbers and zeros, no zeros, and nothing that's all positives. So they're so far on even footing. I do have a slope here of 4, so I would like to choose an x value that is a multiple of 4. That's not going to happen here either. So it's not going to matter. All right, so let's see. Which one do we like? I like negative 5, 2. So I'm going to let my x1 be a negative 5 and my y1 be a 2. And we're looking for ax plus by equal to c. I'm getting marker all over my speaker on my computer because I do this when I'm pressing buttons. Oh, Lord. It's going to be a mess. What can I say? This whole thing is just going to be a mess. My house, not this. This is good. We're good here. Okay, so Substitutions. Y without the subscript stays the same. So y minus y1, which is 2, is equal to a negative 1/4 times x minus x1. So minus a minus 5 is plus 5. All right. I need to get to standard form. That's x's and y's on the same side, no fractions. Since I have a fraction, I'm going to multiply both sides of this by 4. That's going to give me a 4y minus 8 equal to 4 times a negative 1/4 is a negative 1x plus 5. Just like before, this second set of parentheses is protecting the multiplication by 4. Once it happens to the 1/4, it does not go any further. All right, so simplifying again, 4y minus 8 is a negative x. 1 times x is negative x minus 5. I need my x's and y's on the same side. So I'm going to eliminate the x from the right side by adding it to both. This gives me x plus 4y minus 8 is equal to a negative 5. Now I need to get the 8 over on the other side, so I'm going to add 8 to both sides. So I have x plus 4y is equal to 3. If this is the correct equation, I should be able to put a 7 in for the x and a negative 1 in for the y. So that would be 7 plus a negative 4 and get a 3. I'm good. I am good. There we go. Okay, 4 examples there. Hopefully those went all right for you. Because the next thing we've got is horizontal and vertical lines. Horizontal and vertical lines we have done once before. This is a matter of inspection and sort of memorization. You need to remember which one is a vertical line and which one is a horizontal line. A vertical line that passes through the point 7, negative 1. It is up to you to remember that a vertical line is the line that goes up and down like this. The slope of a vertical line is undefined. And the vertical line intersects the x-axis. And the equation can be found by simply calling out x equals and then determining from your point what x is. 7. That's the equation of the vertical line. The horizontal line, remember the horizontal line is flat. It goes left and right. That's your horizontal or horizontal. It intersects the y-axis. And so we look to the y value to write the equation. Done. Dun, dun. If we don't know a slope, write the equation that passes through the points negative 1, negative 3, and negative 1, 2. We simply want to find the slope. So my m value would be 2 minus a negative 3. Minus a minus is a plus. And negative 1 minus a minus 1. This gives me 5 over 0. You cannot divide by 0. This slope is undefined. What I need you to recall or remember here is that an undefined slope is a vertical line. The vertical line crosses the x-axis, and so my equation is x is equal to a negative 1. We want our x value. Now, similarly for number 4, we don't have a slope, but when we go to find it, we have y2 minus y1 over x2 minus x1, or 0 over 12. This is 0. We're again asking you to link a 0 slope with a horizontal line. A horizontal line crosses the y-axis, and so we use the y value to write its equation. We're doing a bit of analysis here. When given several points of a vertical line, your x value will always have to be the same. In this case, x is equal to a -1, because that's how we've described our line. All of our x's are -1. Similarly, when you have a horizontal line, it's the y value that stays the same. Thus, the description of this line is all about the y's. We're only going to describe the y's. They have to equal 2. X values can be anything. That will give us a flat or horizontal line. Right. Can you write linear equations that model the data? Here we have a pole vaulter. Yeah. The diagram is showing the position of the pole at several points during the pole vault. We're going to ignore the one where the pole vault has a curve, and we're going to deal with the pole vaulter in positions 1, 3, and 5. And we want you to write the equations of these lines of the pole vault. What's that called? Of the vault? I don't know. I didn't do track and field. The vault pole in the slope-intercept form. We want you to write the equations of the pole here in slope-intercept form. So in order to do that, you need to know 2 points. Well, if we look at line number 1, if we look at position number 1, we have a point at 5, 2, and we have a second point at 10, 0. As a matter of fact, because you plant the pole and spring up, all 4 of these positions involve that point 10, 0. So we'll be using that particular point for all of the positions. For number 1, our slope will be 0 minus 2 over 10 minus 5, which is a -2 over 5. Then we will have y minus y1 equals mx minus x1 for our point slope form. Our substitutions will give us y minus, I'm going to use this 0 one. I'm going to use y minus 0 equals a -2/5, and then I'll have x minus 10. Look at that. That 10 is also a multiple of the 5. Sweet. Okay, so now I've got y is equal to a -2/5 x. A -2/5 times a -10. Negative times negative is positive. 2 times 10 is 20. So 20 over 5 is a +4. And I have the equation of the first position. Let's do the equation of the second position. The equation, oh no, not the second. I don't want the second. That's the curve. I want the third position. The third position uses, what's this? That's 9. 1, 2, 3, 4, 5, 6, 7, 9, 7. And 10, 0. Oh, I don't think I've ever talked about it, but you always want to put parentheses around points. Many of you don't do that. If you leave the parentheses off points, it's going to mark it wrong. I hate that I said that in the last section. So hopefully you know that by now. Now I've got another song in my head. And I got to fill. All right, so, sorry. I'm a little distracted today, I guess. So my slope would be 0 minus 7 over 10 minus 9, or a -7 over 1. Oh, I like that, -7. Okay. So then I have y minus y1 equals m times x minus x1. I like -7. There we go. I like using that 10, 0 because I love using positive numbers and zeros, and because that lovely 10 worked out so well for me before. So this is going to be y minus 0 is equal to a negative 7, x minus 10. Oh, that's not going to work very well. But I need it in slope-intercept form, so y minus 0 is just going to be a y. Distributing the 7 minus 7x plus 70. And that's it. I have it in slope-intercept form. Minus 7x plus 70. Okay. Then I just need to do the fourth one. And the fourth application is when the pole, look at that, is vertical. When the pole is vertical. And what do we know about a vertical line? A vertical line crosses the x-axis. So we use that x value as our equation. X is equal to 10. And that's it. That's all she wrote. That's all I need for that equation. That vertical line doesn't go two directions. It's not oblique. Can't make a triangle out of it. It can only go up and down. So I only need one letter. And because it crosses the x-axis, I know that needs to be the x. All right. Good. How many other examples? Oh, I got two more. Okay. Diagram shows the amount of milk an average American drank in 1 year from 1980 to 2011. A straight line is being used to model the data. Using the two highlighted points, the 528 and the 2524, find the equation and write that equation in slope-intercept form. Okay, I can do this. I got 2 points. I've got to write the equation. When I've got 2 points and I need to write the equation, the first thing I want to do is find the slope. Okay, slope would be 24 minus 28. Those are my y values. Over the difference in the x's, that's 25 minus 5. So negative 4 over 20, which is a negative 1/5 if I simplify it. So y minus y1, point slope form, equals mx minus x1. My y1 and x1, I got to figure out which one I want to use. Okay, so here's my y2, x2. And here, so I want to use 528 or 2524. They're both positive. Neither have zeros. So they're not winning in that direction. I have a denominator of 5, and both my x values are already multiples of 5. So I'm going to use the smaller numbers. Okay. So that tells me I'm going to use this one. So I'm going to have y minus 28 is equal to a negative 1/5 x minus 5. I need it in slope-intercept form. So y minus 28 is equal to a negative 1/5 x, and a negative 1/5 times a negative 5. Negative times negative is a positive. 1 times 5 is 5, divided by 5. So it's going to be plus 1. Then I'm going to add 28 to both sides. So y is a negative 1/5 x plus 29. I'm going to squeeze this in. Plus 28 plus 28. All right. So that's going to be the equation of my line. Y is equal to a negative 1/5 x plus 29. Now, part B says predict 2028. Okay. Predict 2028. Well, it's worth noting that I'm not putting 2028 in for the x. That the x's here, 5, 10, 15, 20, 25, 30, are counting the number of years after 1980. That's where they added the difficulty here. This isn't year 5, 10, 15, 20. This is 1980 at 0. This is 85. There's 1990. 1995. There's 2000. This is 2005. And that's 2010. So if we're going to predict 2028, we need to figure out how many years that was from 1980. So I'm going to take 2028 and subtract 1980 to get 48 years away. Right? 2028, 1980. Yes. So I'm going to use 48 as my x value. Then I have y is equal to a negative 1/5 of 48 plus 29. What's that going to give me? There's my calculator. Plus 29. And I get y is equal to 19 2/5 gallons. Tried to trick me with those years, but I caught him. Snaps for Amy. Okay. All right. Problem number 3. Okay. So honestly, I made this up. I don't know if the date is right, but the PFAS are PFOS are a forever chemical that's used in a lot of things, Teflon coating on pans. But the big deal here in La Crosse is that it's used as a foaming fire retardant, and that the airport here in La Crosse has been using it in its trainings for years because there's nothing else to use. And it's invaded the water system. And it's all over French Islands water. So it's kind of a big deal. I thought I'd make up a problem about it. So the PFAS is a forever chemical that's used in Teflon coating on pans and is a foaming fire retardant. Because of its ability to contaminate many water sources, many areas are reconsidering its usage. So they're looking again at how it's contaminating. In 2008, the average PFAS levels in the U.S. were 35 micrograms per liter of water. In 2014, that had decreased to 23 micrograms per liter of water. So because people stopped using it, its prevalence in contamination decreased. Write a mathematical equation describing the linear relationship between the years past and the PFAS levels in milligrams per liter. Use this answer to predict the average PFAS levels in 2021. Okay. All right. I'm going to, in 2008, the PFAS levels were 35 micrograms per liter. So I'm going to use 2008 and 35. Now, if I wanted to make this slightly simpler, I might just use an 8 and 35. Maybe because it's 2008, I'll just assume we start in 2000 and I'll do 8, 35. That will make my numbers just ever so slightly, and it should not affect my answer as long as I remember to add the 2000 in there. Okay. And then my second one is 2014. So since in 2008, I just used an 8, in 2014, I should just use a 14. And then those were 23 micrograms. Write a mathematical equation that describes the linear relationship. Aha, linear relationship. We're doing lines, and writing equations of lines is y minus y1 equals m, x minus x1. That's how I know. Okay, so I've got 2 points. M would be the difference. So I've got 23 minus 35 over 14 minus 8. 23 minus 35. I didn't want to do that one in my head. Minus 12 over 6. And that's a negative 2. Okay. So now, my slope is negative 2. Great, it's not a fraction. I was thinking this would be a fraction. Thank God it's not a fraction. Okay, so now I need to choose, do I want to use the first point or the second point? I don't think it matters. They're both positives. None of them are zeros. I'm sticking with the smaller x value. So this is going to be y minus 35 is equal to a negative 2 times x minus 8. So I have y minus 35 is a negative 2x plus 16. I'm going to add the 35 to both sides. Y is a negative 2x plus 51. This is a linear equation in slope-intercept form. Equation linear describes where y is the year and x is the milligrams per liter. Micrograms, I should say. That's a microgram per liter. Okay. What does this mean? This means that every year the microgram per liter drops by 2, but they must have started at 51. So it could have been as high as 51 in 2000. All right, so for part B, we're going to predict 2021. So because of the way I did the points, because I did 2008 is 8 and 2014 is 14, I want my X value here to just be the 21, right? I ignored the 2000. So this would be Y would be a negative 2 times 21 plus 51, or a negative 42 plus 51, which is 9. Okay. So use this answer to predict the PFAS levels in 2021. It should be 9 micrograms per liter. So it should be 9 micrograms per liter. There we go. Done it all. So what have we done today? My hope is at the end of this, you have knowledge on how to use the point slope form to write the equation of the line, whether you're given a point and a line or whether you're given 2 points, that you can feel comfortable writing both horizontal and vertical lines, and that you've seen a few examples of how to write linear equations when you're modeling data, when you're given some data and some information, possibly a graph, possibly just the straight data, that how you would use that to write the equation of a line. If you need clarification on anything or if you have any questions, please don't hesitate to contact me. If I'm not available, please feel free to drop into the Math Center. Julia would love to help you, as would several of the tutors there. All right? Thank you. Have a good night.